Hi folks, let's get started. Hello. Yes, it's me. Hello, my name is Pamela. I'm a developer advocate at JetBrains. Welcome to my talk, Kotlin Multiplatform Mobile for Skeptics. Now, you're probably wondering, what is a Kotlin talk doing at a Java conference? And what is a mobile talk doing at a predominantly back-end-ish conference? It's a very good question. I'm not sure myself. But Kotlin is Java. A lot of times people say Kotlin is Java, like Hadi says Kotlin is Java. I'm talking Kotlin sometimes, so let's just go with that. But the nice thing about this technology is that it can extend to the desktop and server backends as well. So what I'm going to teach you today is very mobile specific, but the multi-platform technology can be extended to things on the JVM, it can be extended to JavaScript, it can be extended to WASM, it can be extended to iOS, which is what we're going to be talking about today. So let's get started. Today we're going to be having a look at a few of the following things. I'm going to start with a brief introduction on what KMM or Kotlin Multiplatform Mobile is and why I think it's worthwhile convincing you to give this technology a try. Then I'm going to show you how it actually works with a simple code sharing exercise. Of course, one of the most important parts of a talk for skeptics, maybe you're a skeptic, you're an iOS developer that somehow got lost, and you're a skeptic about this technology. This is the part where I'll be convincing you to give this technology a try. And in the last section, I'm going to be sharing some resources that I found that's really, really helpful. And the one resource actually helps with desktop development. So if you're keen on learning how to do desktop stuff, one of those resources would be good for you. So let's start with the introduction. So what is Kotlin Multiplatform Mobile? It's an SDK by JetBrains, and it allows development teams to share common code between iOS and Android platforms. So I was traditionally an Android engineer before I went into developer advocacy. So I know all about the things from Android, but not so much about iOS. So the really cool thing about KMM is that it doesn't impose restrictions on your non-shared code. What does that mean? It means that it doesn't dictate what you share and what you don't share, especially not what architectures you use. So for example, you can share a really important algorithm like validation or something like that, and the rest you can just code natively as you want. And that's a really powerful concept that's different from things like Flutter and React Native. So how does it actually work? Well, we've got this multi-platform mobile shared module that you'll see there in the center that compiles using some really cool technology into platform-specific artifacts that you add as a dependency in your app. On the left-hand side, we've got iOS. So we use the Kotlin native compiler to compile into framework files or CocoaPods, but that compiles into native binaries. And that you can actually go and use in your iOS app. You can add it and use it in your iOS app. Then on the right-hand side, you've got Android. So Android uses the Kotlin JVM compiler that you're all familiar with somewhat, maybe, JVM at least. That creates jar files that you add and use from your Android app. So I've mentioned that you can share code between different platforms and that the decision is yours on what you share and what you don't share. But there are common scenarios of code sharing. Now, this diagram is very common for a front-endy kind of technology, like you have your data layers at the bottom, your business domain, presentation, and UI. So if you were, for example, building something like a web application, you might go through this kind of thing. Okay, so in this slide, we see that we're showing the data and core layers and the business and domain layers there at the bottom. But we choose not to share the presentation and UI layers, the views. And that's fine, we can. But we can also take it one step further and share the presentation layer of presenters, view models, and controllers as well. To reiterate, the choice is yours. And from about Monday, we're starting to develop a technology that will allow you to also share the views. So it will be Jetpack Compose on Android and Compose for iOS on iOS. There is a Compose for desktop as well. There won't be a Compose for backend because what are you going to do with a UI for backend, right? There is a very cool thing called, I think Maya, it's called Mosaic, that does it's a command line interface for Compose, which is really cool. Am I right, Maya? Yeah. Okay, so what are the benefits of multi-platform mobile? Firstly, it's about flexibility, to choose what is shared and what is not shared. If you just want to share that important algorithm and take things from there, you can. And secondly, it lowers the cost of the effort, and it's basically about effort and cost per feature. So if your team doesn't have to duplicate the effort on iOS and Android to ensure that it works correctly on both platforms, and this is going to drive down your development costs and your testing costs as well. So, and lastly, your shared code ensures that consistency amongst platforms. So I've seen it so many times that Android and iOS developers have a slightly different understanding of what's happening on their platforms. Like, for example, you have this feature, and this happens the same with web. Like, you have a feature that you want to develop on Android, iOS, and web. And they have a slightly different understanding of what they want to be done on, of what actually this feature means and how I actually encode it on my platform. And this results in slightly nuanced implementation differences. I'd like to give you a real-world example of where I found this problem and where multi-platform mobile would have been a perfect solution for this. So I was working at a fintech institution a couple of jobs ago, and I was working on the onboarding team. So when we onboarded a customer, we needed to get a bunch of information and documentation that helped us to sort of figure the customer into our financial system, and it was based on their country. So each country had its own rules, and we supported different countries. And so if we weren't really, really careful, we're going to encode that business logic incorrectly on or differently on both platforms. So we really had to push very hard into our product managers documentation and manual testing. That's really gross, but that's what we had to do. In retrospect, something like either server-driven UI, but that also constrains you can't go offline, server-driven UI, or something like multi-platform mobile would have been a perfect use case for sharing that business logic across platforms. So next, let's see how it works practically. Note, I'm not going to do a live coding session, not because I'm scared, but because of the time it takes to download both Android dependencies and platform dependencies. So the Android SDKs and also all the goodies that goes together with KMM. And I'm sure you don't want to sit here for like 11 plus minutes and sit and watch downloads happen. So let's not go there today. Let's just look at slides. So these are the tools that you're going to need to share code with KMM on Android and iOS. You're going to need Android Studio, which you can get for Frizzles, with the Kotlin Multiplatform Mobile plugin that just went into beta that you get from the marketplace on Android Studio or IntelliJ. You can also use it with IntelliJ if you like it. You also need the Java development kit. So there is Java in this after all. And you also need Xcode. Please don't boo. Please don't boo. Okay, Xcode on macOS from the App Store. So you are going to need a Mac to develop multi-platform apps. And this is the Apple requirement. And it's also like a way to get a really cool machine from your boss. I would recommend the M1 Max, but Yeah. It's lovely. It's very fast. It's good for video editing too. So there is a tool called KDoctor that will help detect whether your environment is set up correctly. It's really cool. I struggled with setting up my environment for a while because we didn't really cater yet for M1s. But we sorted that out and everything is fine now. So KDoctor really helped me, and I'm sure it will help you if you're interested in KMM. So we have this plugin for IntelliJ IDEA or Android Studio for multi-platform mobile development, and you can get it from the marketplace, as I said, and it will make your development just that much easier. You can create both a multi-platform project and a library, so you can do greenfields projects and brownfields projects. You can share code, you can write your shared code once and then share that code between Android and iOS. You can even run your iOS apps from Android Studio and debug it. Pretty cool. So I want to show you how it works. And this is the default example that we have for KMM when you run through the wizard. So the example shows a little bit of text on the screen with Hello Android 31 on the left-hand side. That's the Android emulator for Pixel 4. And Hello iOS 15.5 and on the right, and that's the iPhone 11 emulator. So it's a little outdated, but it's fine. So 31 is the SDK, the software development kit version of the Pixel emulator, and iOS 15 is the iOS version of the iPhone 11 emulator. So it's device-specific information. So I've taken some screenshots just to show how the plugin creates a project. So we're in the new project wizard, and we can select Kotlin Multiplatform App to create an app from scratch. And then we have a plugin that asks a whole bunch of information. I'm not really sure if you can see that well, but the most important really is this minimum SDK, which tells you, well, obviously the name as well, you have a nice funky name for it, but the minimum SDK tells you what, firstly, the percentage of people that will be supported by this device, by this application, and you see it's pretty high there, but it's also like the software development kit on Android that you're supporting, at least the minimum. So the next thing that we can do is that we can configure our project that consists of Android and iOS, and we also have our shared module, so we can define the names that we're going to give there. In the screen, we also decide how we're going to distribute shared code to Xcode. We can easily go the easy route or the hard route. So regular framework files is the easy way, and CocoaPods is the hard way. But why do you want to use CocoaPods? Because that's how you're going to do it in production. Okay. Mike, can I have some water, please? Give water, please. Thanks. Once the plugin has done its magic, so it's generating, and then, as I mentioned, it takes some time, so it's not entirely magical. This is what the project structure will look like. We've got our Android app over there. That is our actual Android app. Figure that. We've got an iOS app, which is the iOS app. So when you open it in Xcode, that's where you're going to go looking for it. And we've got this shared module. I think 3 people are bringing me water now. Thanks. Thank you. Okay, I feel better now, thanks. The shared module is called shared, and it contains 3 directories of Kotlin code. Now, we've got commonMain, where all our shared code is. We've got androidMain and iosMain, and that's where all the Android or iOS-specific integration code that integrates with the shared code is. Now, this sounds a bit weird, but I'm going to explain it now. So maybe you have a couple of questions that's running through your mind right now. And maybe the first one is, did she really say that shared module was all written in Kotlin, even the iOS parts? Yes, it's all Kotlin, even the iOS parts. The reason why is that iOS integration code actually accesses, it enables you to access native binaries through Kotlin. That's the way that the Kotlin native compiler actually works. And it gives you access to platform-specific functionality like device information, which you don't normally get elsewhere. So that's where the 31 and 15.5, the SDK version and the iOS system name and system version came from. So this is how it all fits together. So we've got our shared code in the greeting file. What we're going to share is just a simple exercise. It's just a greeting, like hello something. And then on the iOS side, on the left-hand side, we've got the iosApp, which is ContentView, which uses that shared code. And that makes use of a platform class that accesses iOS APIs to get that system name and system version. So that's what's happening on the left-hand side. On the right-hand side, we have the main activity that uses the shared code, that greeting. And on that shared code makes use of the platform class to access Android APIs to get that SDK version. So maybe you're wondering, like, show me the code. Let me show you the code. Okay, so here we have commonMain's greeting file. So this is nice in Kotlin. You can see by the KT extension in greeting. And it contains the greeting class that also has a greeting function. And that function just returns hello platform.platform. Now this is nice, funky Kotlin code for string interpolation, that dollar with the little curly braces. That's string interpolation. So it will put the SDK version or the iOS version in there. Next, we have commonMain's platform class. Now, remember, that's where all our shared code is. But we're defining a class called platform, and inside it, it also has a property called platform. That's where we're going to store our platform stuff. But something really important to notice here is the keyword expect in the class definition. It's a new keyword in Kotlin. We can do that because it's our language, right? JetBrains is the writer of Kotlin, so we can define new keywords as we want. And it tells us that the code that we're looking for is going to be found in the platform-specific integration code. So AndroidMain and iosMain. Okay, let's have a look at AndroidMain first. So we're looking at the corresponding class to that platform class in commonMain. We're looking at platform class in AndroidMain. And it has a matching platform called platform. Okay, and we're assigning Android and then this long string interpolation that is basically the SDK version of the Android device that you're running on. But I want you to notice something else here that's quite interesting, is that it has quite a number of actual keyword, a proliferation of actual keywords. And that is basically telling us, it's also a new keyword in Kotlin, and it basically tells us that whenever you have this expect keyword, it matches this actual keywords so that they correspond to each other. And whenever you're looking for the actual platform implementation of what was happening in commonMain, here it is. Ta-da! Okay. This is now iosMain. So we're going to look at iosMain's corresponding class. It also has a platform property. And if we were running we're basically here using real iOS device classes, properties and functions to get stuff from the device. And if I run this on my iPhone 11 emulator, it will say iOS 15.5. So the system name is iOS, and the system version is 15.5. And notice also here that we have quite a lot of actual keywords that we're using to indicate that this is the actual iOS-specific implementation. Okay, how does this get on the screen? Now, this is probably unfamiliar to you, but now is your chance to learn a little bit of Android. So this is our main activity, and activity is just something that you put, it's just a screen, basically, on Android. So when you launch your Android application, it's a screen that's called the activity. And for Android, we have things like text views, which are views that you put on the screen. And by setting the text, you can see that lower over here, you can see by setting that text property to greeting.greeting, we are invoking our shared code, and we're setting the text property of the text view to hello Android 31 or something like that. So this is the old view system of Android. We have migrated our wizard to Jetpack Compose, which is really exciting technology, and it's based on declarative UI, which if you're familiar with React or something like that, that's really like analogous to that. Something in the iOS world that's similar to that is Swift UI. But I want you to notice something. It's really easy to call that shared Kotlin code from our Android app and display it on the screen. But the question is it going to be as easy on iOS? Maybe, maybe not. Okay, this is iOS. So another chance to learn something new. So this is Swift code. So iOS develops either in Objective-C or Swift. And we define our application like this. So this is called Swift UI, and it's also a declarative framework. Maya is going to be talking tomorrow about declarative programming, and that will be your chance to understand exactly what that means. I hope that you attend her session. She's an excellent speaker and also my best friend, so please attend. So let's drill down into, so we have our iosApp, and then we also have some other stuff inside of it, and including this content view. But the content view is where we're actually going to have our screen stuff inside. So let's drill down into that. And this is content view. So we're defining a constant in Swift called greet. Okay, so constants in Swift is used with the let keyword. So we're defining this constant, and we're assigning the value greeting.greeting to it. And then we have a view, a body view, and we just have a text element, which we take that constant and we plonk it inside that text element. So the question that I posed to you in the previous slide is it as easy calling Kotlin code from Swift as it is calling Kotlin code from Kotlin code? And the answer here is kind of yes. In this easy example, it is. It gets more complicated, but if you keep things simple, it will definitely stay easy. So to run our apps, we have these configurations called androidApp and iosApp configurations on Android Studio that you can use to run the Android emulator and the iOS emulator. And see on the left-hand side, hello Android 31, and hello iOS 15.5 on the iPhone 11 emulator. And that's how KMain works. So what did we just do? We created some shared code. That was the greeting, hello, platform. We used the shared code in Android and iOS. That was the main activity and the content view class, structures, the content view Swift stuff, and the main activity Android stuff. And then we used platform-specific functionality from that shared code, those platform classes. That's really powerful. Just a second. I'm going to not balance this. Okay, now we get to the tricky part. The part where I try to convince you to give this technology a try, even if it's just in a toy project. I hope you do. It's quite fun. So before I investigated Kotlin Multiplatform Mobile, I had very critical opinions of the technology. I wasn't sure if it was going to work, and I wasn't sure it would be widely adopted. So obviously, I was not a developer advocate for the technology at the time. That would be awkward. but here are some of my initial thoughts. So first, I thought iOS developers won't want to adopt this. It's really important for us that iOS developers also want this technology. It's natural for somebody, for example, in a Java community to want to only stay in Java. Why would they want to learn stuff like Swift or Rust or things like that? So it's natural for somebody in that particular community to want to stay on that platform and perfect their knowledge and become experts in that technology. They're invested, and asking them now to go on the side and learn this other technology might be outside of their comfort zone. Next, I thought, is the interop going to be weird? So will the Swift to Kotlin and Kotlin to Swift interop not be clunky, and am I going to have to deal with either ugly Kotlin code or ugly Swift code just to get it to work? Of course, then I thought also about the cost of development. Will this really lower the cost of development? There's more to the game than saying there's less code because we're sharing it, than just saying there's less code, so there's less cost. There's other things to consider. For example, training, skills development, time to get used to and very, very productive in the technology. And lastly, I thought, isn't it going to be more frustrating than developing 2 native apps or using something like Flutter or React Native? Native platforms and these 2 cross-platform technologies have huge support from companies for native apps, Apple and Google, and huge ecosystems for example, for Flutter, which comes from Google, and React Native, which just comes from the community. They are way ahead of the game. As you can see, I didn't really have a very positive picture about multi-platform mobile in my mind. But something kept bugging me, and it wasn't the job on the career side for JetBrains. I loved Kotlin, and I trusted JetBrains as a company. I was an Android engineer. I started out with Kotlin. I loved Kotlin. So I wanted to give multi-platform mobile more than a fair chance, apart from my preconceived ideas. So I went through a whole bunch of information and resources, and I'll share a link to all those resources at the end of my presentation with you. So I started with some light-hearted watching and reading, and I watched a few short tutorials that you can find on our JetBrains Kotlin YouTube channel, and they demonstrate how to get your environment set up and how to do a few easy apps. Then I had a look at who was using multi-platform mobile on the use case site for Kotlin multi-platform mobile. Big names: Netflix, Philips, VMware. Yes, Cornel, VMware. Nice. Okay, next I saw a tweet by my former colleague, Malcolm Kwenda. Now, Malcolm is an iOS engineer at Luno, and he also investigated the tech and wrote this hot tech article about it. And finally, I watched the Talking Kotlin. I don't know if you're familiar with that podcast is, but it's basically just talking about cool stuff we're doing with Kotlin, with Hadi Hariri and Sebastian Eigner. And the topic for that podcast was why iOS developers at Todoist, the To-Do app that maybe you've used before, actively pursued using multi-platform mobile on their app. And I started seeing the potential in this technology. People were using it, they had a good experience with it, and they were getting excited about it. And so I decided, okay, let me do a deeper investigation with some books. I don't know if you guys are book people. I'm definitely a book person. I like the smell of books. I like the way it feels. I like collecting them. It's a little nerdy, but anyway. So I had these 2 books, Simplifying Application Development with KMM by Robert McGee. And the one that I would really recommend, especially if you want to go into desktop application, is Kotlin Multiplatform by Tutorials by the Ray Wenderlich team. They're a little expensive, the Ray Wenderlich team books, but they are excellent. Maybe work will pay for it, and then who cares? So this gave me a really solid foundation on how the application works, how that technology works. But since I'm giving this talk, and since awkwardly I'm a developer advocate for this technology, something must have changed my mind. And the first thing that really changed my mind is this article by Malcolm that you can find on Medium. and that resource article will have a link to it. I knew him, I respected him. He's a very gifted iOS developer, but he's an iOS developer. And he was willing to give a technology outside of his ecosystem a chance. And I thought he had a really balanced view about it. So there was a hope for this technology after all. For my research, I concluded a couple of things. So multi-platform mobile won't take the fun out of native development. You can do Jetpack Compose on Android or the View system if you're feeling old school. And on iOS, you can do Swift UI or the old UI kit stuff if you really want to. But it also has to do with the team deciding what they want to share, and the rest they can code natively to their heart's content. By enabling a team to share across platforms, you can have consistency amongst those platforms. This is really important where complex business logic is concerned. You write once, you test it well with some unit tests, and both platforms will work the same. I could see that it could also lower the cost of development, not in terms of money, but it will allow you to go faster. I also realized that initially there's going to be a lot of learning and maybe some frustration to go with it, but that the pace would pick up over time. There were also already a number of mature libraries supporting multi-platform mobile. Ktor, which I don't know if you know about it, it's a server-side technology, but also a client-side technology from JetBrains for networking. Coin for dependency injection, which you can use anywhere. You can use on the desktop, on the server, or whatever. SQLite and Realm for databases. Maybe you've heard of Realm. And more is being added to the list as the ecosystem grows. I also saw that it would help under-resourced teams. For example, in South Africa, there's a lot of Android engineers, but not so many iOS engineers, and this is going to lift some weight of responsibility from time-constrained iOS engineers. And lastly, I trusted JetBrains. So when Google decided to make Kotlin one of the most primary languages for Android, it was a rock-solid technology. So JetBrains worked for many, many years, I think almost just under 10 years on Project Kotlin before releasing version 1.0. And by that time, it really was rock solid and was ready for adoption. And I think that similarly, JetBrains is committed to making this thing working great. But of course, I've done some research, but that doesn't mean that I don't have questions and doubts. And here are some of the things that I'm still wondering about. So a criticism that I've seen of multi-platform mobile is that other cross-platform technologies have bigger ecosystems, like React Native, for example, has a huge ecosystem of libraries. And it's really important when you start out with the application to kind of know beforehand, okay, I'm going to need this and this and this libraries. And make sure that what you need is already available, because otherwise you're going to have to write it yourself. That's maybe not so ideal for going fast. Something inherent in new technologies is also around support. So documentation, tutorials, books, code samples, and there must also be a thriving community around multi-platform mobile. So what I've seen, so JetBrains has a lot of resources, and they're kept up to date pretty much, and from the JetBrains side. But sometimes you find code samples from the community that are a little old and a little weird. So you have to be careful where you go for answers. But I don't know if you know about Kotlin Lang. It's a Slack workspace where JetBrainers and Kotlin enthusiasts from all over the world get together and talk about Kotlin and ask and answer questions. So if you're looking for an answer about Kotlin, that's where you should go. It's free to register. You just go to kotlinlang.org, find the Slack workspace and register and just ask questions. There's a beginner channel as well. My last point has to do with my lack of experience on the iOS platform. I was an Android engineer, and I am learning Swift and iOS sort of on the side, and I have no idea what a professional iOS engineer will feel like coding with multi-platform mobile. Will they be okay coding in either IntelliJ IDEA or Android Studio and then using something like Gradle? Or are they going to get frustrated if there's no Android engineers to help them? But I also wanted to do due diligence, and hear what others had to say so I could have more of a balanced view about what I was saying. So I went to the source of all truth and all opinions, Twitter. And this was my tweet. Hey, mobile dev Twitter, have you used Kotlin Multiplatform Mobile before? What convinced you to give it a try? What convinced you that it's to use it in more than just a Play app? And it certainly sparked a very interesting debate. I would like to go through like the points that the different camps made, but I decided to summarize and anonymize it. The reason why is just to keep it brief, but if you're really curious, there's a link to the tweet here at the bottom that you can go check out. It really did happen. And I'll be sharing the slides, the link to my slides at the end of this, so you can really go super snoop if you really want to. So, first up, we have anonymous Flutter Guy, who was a Google developer expert for Flutter and Dart. So not entirely independent. And this was a summary of his points. He felt that not sharing the UI is a huge con, and that's the real time saver. He felt that the language shouldn't be the center of a tech decision. So in other words, don't use multi-platform mobile because you love Kotlin. He also said, rightly so, that the resources behind multi-platform mobile can never match the resources Google puts into Flutter. Now, this is kind of, because this is before our beta launch, which only happened on Monday, this is kind of an outdated sentiment because Google has gone ahead and taken all the some of the Android libraries called JetBrains and made them multi-platform. So not quite true anymore. So in summary, he felt that multi-platform mobile had questionable advantage and a questionable future. Ouch. Okay. Next, we had some anonymous multi-platform mobile guys answering our Flutter Guy. And here is a summary of what they said. Writing and testing business logic once has a huge advantage. You don't have to commit your entire code base to a new technology like Flutter if you were to adopt Flutter or React Native, or maybe you decide to go native. You can start small and then keep adding. It also creates better looking native UIs than the material design first approach of Flutter. So your iOS apps won't look like Android apps, they will look like iOS apps, really slick. And lastly, some of your cross-functional team, your Android engineers, are already familiar with the tools and language. So Kotlin and Android Studio. And lastly, we had an anonymous, why is that word so hard? A Googler that decided to round it off the discussion quite nicely. And this is what he said. The language it isn't enough to make a tech decision, but that KMM is different from other cross-platform technologies in that it works with native libraries. So React Native works like you have to create these plugins, and you can use from your app, you use the plugins, and from the plugins, you use the native stuff. But we work directly with the native library so that you don't have to wait for the plugins. And the adoption is also not all or nothing. It's a spectrum based on use case and the needs of the team. So this was a summary of our discussion. It was an interesting debate, and I wish that there was like a really snarky iOS person that could have contributed, but I want to remind you of my favorite iOS engineer, Malcolm, that had this post about KMM, which I'll share the post to at the end of my presentation. I think you'll find it really insightful what he has to say. And with that, we're near the end of my talk. I hope that I sparked maybe an interest in you to investigate Kotlin Multiplatform Mobile. maybe just beyond giving it a thumbs up and thumbs down, I hope maybe you think, maybe I should write my own app. I have an app idea. Maybe I should write my own app with KMM. It's a technology with huge potential, and I hope that I've convinced you not to just dismiss it outright. If you want to look at my slides again, you can. The bit.ly is basically just KMM Skeptics slides. And similarly, the resource article is KMM Skeptics resources. It basically adds where I found all my information plus my opinions so that you can decide where you want to spend your time the best. And with that, thank you. Stay in touch. Have a look at my blog. There it is. And if you are really interested in Kotlin, accessibility, or Android, stickers. Yes. Yeah, cool. Any questions? Do we have time for questions? Yes.
So I saw a feature where you could choose between Apple and iOS. Does that mean in the future we'll be able to run an iOS emulator inside Android Studio?
So the question was, can you run an iOS emulator inside Android Studio? The answer is no. You still have to use Xcode to run that emulator, but you can run via Android Studio or IntelliJ.
The second question is, does JetBrains have a full course on KM?
So we are developing, so we went into beta on Monday, and we have this series of webinars. I'll be doing the first webinar called Getting Started on with Kotlin Multiplatform Mobile on the 20th of October. There's also one about databases. There's one about getting your app on iOS, and there's also one on dependency injection. Check out those. They'll be happening for free on YouTube, basically. But there is a walkthrough course, and there's stuff on our Kotlin channel on YouTube, but there's no course. Any other questions?
Thinking about larger application apps, the platform folder or file is going to get very messy. Is that something you've taken into consideration? Because if I need to go and add a method to access any different resource, it's going to become very messy. So I don't know if that's something to take into consideration.
Yeah. So it won't be just a single file with all your platform stuff in. You can just create files at will and folder structures, packages, directories, and you can organize it like you would a normal application. Yeah. Maybe from this side, let's be balanced. Let's make the computer run. I think this will be the last question.
I have multiple questions.
Okay. Just two.
So the first question I have is regarding permission view. Can that be shared? Okay, because I know that permissions are in the slightly different areas.
So permissions will still be different permissions are still going to be different on Android and iOS, but that you can handle on your Android app and iOS app. And the common code, which is not related to permissions and stuff like that, will be in your